Nearly every week we get a call from a new client asking us to help clean up a hacked site or a site that was attacked. We have a lot of experience routing out attackers, although we see new methods of attacks all the time. In order to catch a hacker, I've worked with my team to try to think like one. If it's an e-commerce site, then the most valuable data is usually credit card information. If it's not e-commerce, they might try to vandalize the site or encrypt the contents and demand a ransomware payment to get the data back. So that led me to think, what can you do with stolen credit card information? A hacker could sell the data in bulk online. They could use the credit card information to purchase online goods and services. If they're smart, they won't use a stolen credit card to ship items to their own house. But it led to me thinking, would it be possible to take credit card information from online and actually create a cloned credit card that works? I wasn't sure, but I was curious. So I purchased a magnetic card reader and 25 blank magnetic cards on eBay for about $70. When it arrived, I plugged it into my computer via USB and downloaded the MSRX software onto my computer. I then started to scan everything in my wallet, mostly to see what was encoded on the magnetic stripe. It's kind of cool. My driver's license, for example, it contains my full name and address. My Costco card contains mostly a membership number. Same thing for Qdoba, a burrito place, and my health club too. Same kind of, it has a member number that is read by swiping the card and then verified by an online database. My King Soopers card from my local grocery store, it contains the store ID, I think, as well as my membership ID number. It's something like 600301702246191 equals 3400. And I've changed the numbers so nobody can clone my King Soopers card and start using my fuel reward points. The information is encoded onto 2 of the 3 tracks on the magnetic stripe. That way, if the system can't read one track or it's damaged, it can try the other track. Next, I decided I would try to clone the data on my King Soopers reward card and write it onto a new blank card. The blank card is just a white card with a black magnetic strip on the back. I first had the system read the information, and then I wrote it onto a blank card. The software made it pretty easy to do. And as a quick quality assurance check, yes, I run a web dev company, I then scanned the new cloned King Soopers card and compared the information on it to the original. To me, they appeared exactly the same. But the proof was in testing. Would my new cloned King Soopers card work when I went to the store? So it was time to find out. I decided to use the self-checkout option and bought a tuna poke bowl for lunch. I didn't want to have a checkout person see me swipe a blank white credit card and get overly suspicious. So I went to the self-checkout kiosk and swiped the cloned card. And it worked. Wow, kind of cool. So now on to step 2, cloning one of my credit cards. I scanned in one of my actual real live credit cards and then wrote the details onto a new blank white card's magnetic strip. I wasn't able to do anything about the chip, but I wondered if I would be able to use the card anyway due to a chip reader failure that would fall back to the magnetic stripe. So I went to the grocery store and used my cloned loyalty card again, which worked, and then I tried to use the cloned credit card in the machine. But it didn't like the fact that I was trying to swipe the card instead of using the chip. So after a couple of attempts, I paid with my real credit card using the chip method. I then went across the street to the gas station. Why the gas station? Well, they still use the magnetic swipe system. The pumps haven't been upgraded to use the chip and that feature. Again, I used my cloned King Soopers credit card, or King Soopers card to log in and get my loyalty rewards. In this case, I saved 3 cents per gallon. My car has a big tank, so any discount is pretty helpful. Then came the moment of truth. When my cloned credit card worked at the gas pump, I swiped it in, and the system asked me for my zip code, which I entered, and then it let me pump gas. So step 2 was complete. I was able to copy one of my live credit cards and then use it without a problem at a real place. I did need to know the billing zip code, but if I had stolen it from an e-commerce site, I'd have that detail regardless. So what I discovered was that if I was able to skim or secretly scan someone's credit card and figure out their zip code, I could use that information at a self-service gas station without a problem. Now, credit card companies know this and monitor patterns. So if I skimmed a credit card from someone that didn't live near me and started using the credit card at random places around town, and they live halfway across the country, the credit card company is often going to think that this might be fraudulent, and they'll probably flag the card and start the declining process of declining purchases. This actually happened to me once. Someone used my credit card number at a dollar store in New York, spending about $150, which is actually quite a bit of stuff to buy at a dollar store. The credit card company flagged this as suspicious, as I had just also used the card at a local place here in Boulder, Colorado. I wound up having to cancel that card, and I wasn't responsible for the charges of the dollar store. But unfortunately, the dollar store probably had to eat that $150 fraudulent purchase. Okay, step 3, rewriting a new credit card number onto an older card. So what I did was I cloned a credit card onto the equivalent of a blank white card, and that has some limitations. For example, I couldn't really use that at anything other than a self-service location. I wanted to see if I could load my live credit card number and information onto an older credit card, one that had numbers on it and that matched my name that was on my ID. So here's some limitations to this. I couldn't really use the card at a place that has chip technology because only places with older readers that haven't been upgraded would work. And this was becoming more and more difficult to find. Some places, such as OfficeMax, actually require the cashier to take your card from you and enter the last 4 digits of the credit card number into their point of sale system. If the numbers on the card are different than the ones scanned into the system, then the sale is probably going to be flagged as fraud. So I found a store that hadn't been upgraded to the chip reader and just had the older magnetic stripe reader. And it worked. Kind of crazy. Okay, so step 4, creating a card solely from online data. The fourth and final step for me was to see if I could take credit card information of the sort that an end user might enter online and see if I could encode a blank credit card that would actually work. So in order to do this, what I really needed to do was understand what all the information on a card meant. Again, I've changed the numbers and information to protect my personal information. If I posted the actual track information, someone with a credit card reader could then clone my card and use it at gas stations and places that don't yet have chip readers. So here's a look at some of the sanitized raw data that was encoded onto my magnetic strip for a real credit card number. You'll see a % B47800, Appleseed Johnny B 1807, and that's the first track, and then it repeats with a 4780 and a bunch of zeros, and then the plus and a question mark. So, but before I could start the process of creating a credit card with data from an online source, I needed to break down the information on the card to figure out what it actually meant. So there's 2 lines to the data. Magnetic cards contain 3 tracks. The first track can contain up to 79 characters. Track number 2 can hold 40 characters. Most magnetic card reader systems are designed to read both tracks, in case one is damaged. And then the third track is rarely used, and all the cards I scanned, I never found a card with information on the third track. So here's a breakdown of the information on the card. So track 1, there's a start sentinel, and it usually is a percentage, and it indicates the start of the information on the card. And then there's a format code. B, for example, indicates a credit or a debit card. Then there's PAN, the primary account number, which can be up to 19 digits. In this case, it's the credit card number. The first digit of the credit card number indicates the type of the card. 3 is Amex, 4 is Visa, 5 is MasterCard, 6 is Discover. Then the next 5 digits of the credit card number indicate the card issuing bank. Visa and MasterCard usually have 16 digits, Amex has 15 digits in the account number. Then there's a field separator. This tells the system that the account number is complete and that the next field is beginning. Name, so that can be 2 to 26 characters. In this case, last name, first name, middle initial. I'm putting in Appleseed Johnny B. Although it seems like the card is shouting at me by using all caps, I believe this was done to limit the characters for simplicity. It looks like the system is putting in a fixed width for the name field in my case, which is why there are spaces after the middle initial. So field separator, this is a caret symbol. Again, this says that the name is finished and move on to the next field. Expiration date in the year, month format. In this case, the card's expiration date is formatted as 1807, which translates to July 2018. Service code, 3 digits. The next 3 digits of their service code, in this case 201. The first digit, 2, says that I can use this card internationally, but to use a chip wherever available. The second digit is 0, meaning normal. If it was set to a 1 or a 2, it would flag a system to contact the card issuer. The third digit, in my case, 1, sets restrictions on how the card can be used. 0 is no restrictions, but a PIN is required. 1 is no restrictions. 2 is goods and services only, but no cash. 3 is ATM only, but a PIN is required. 4 is cash only. 5 is goods and services only, no cash, but a PIN is required. And 6 is no restrictions, but use a PIN where feasible. 7 is goods and services only, no cash, use a PIN where feasible. After this is what's known as the discretionary data on the card. This could store the card's PIN number, a code that can be used to check the PIN, or other information. Discretionary data is optional, but it can contain what's known as a Cvv2 code. I'm sure you're familiar with the Cvv2 code, the 3-digit code on the back of a Visa or a MasterCard, or a 4-digit code on the front of an Amex. Amex uses a 4-digit code because their primary account number is 15 digits instead of the 16 for Visa and MasterCard. So this 3-digit code is what you have to enter in a lot of e-commerce sites to prove that you have the card in hand. It's not a number that's stored in the magnetic strip. From what I've been able to understand, the Cvv2 code is a computed number that's based on the primary account number, 15 or 16 digits, the expiration date, a 3-digit service code, and then multiplied and calculated against 2 secret encryption keys that are known only to the card issuing bank. So when you place an order online, this 3-digit code is a final step to verifying the card. But the magnetic stripe information contains a Cvv2 code. This is a data point that is written into both tracks of the card. This code, the Cvv2 code, is not something that is ever really used online. It's also likely that the code is just not a plain text number like 1234, but is a number that has been manipulated by an algorithm. Something basic could take the actual number, 1234, and multiply it by an arbitrary number such as 55632, and then the result would be pretty big. That might be the number on the card. My guess is that the calculation is much more complex. If you know the secret number, then you can take the 6864988 number, divide it by 55632, and then know that this correlates with the actual number 1234. Then there's an end sentinel separator, usually set to a question mark. And finally, there's a longitude redundancy check, LRC, that is 1 character. It's used to verify that track 1 was read accurately. If it wasn't, then it might indicate that there's a system error, or to default to track number 2, or just show a card read error. So here's some of the information for track number 2. It'll start with a credit card number like 4780000 and have some basically the same information that's on track number 1 without my name. It also has 2 less digits at the end of the discretionary data. Track number 3 in my case was blank, and it was originally designed as a track that an ATM card could use to read or write information, including an encrypted PIN, your country code, currency units, amount authorized to withdraw from the ATM. But because this could be easily manipulated with a card reader like mine, it's not really used. So back to my original challenge. Could I take credit card information, like the information that I would enter to place an order online, and then encode that into a credit card that would actually work? The biggest challenge was the discretionary data. So, should I leave the discretionary data blank and set it to all zeros, see if that would work? Use discretionary data from another card to see if that would work, because perhaps the card reader didn't really use this information anyway? Or just give up and not try this because it's a little crazy? If I used the card at a gas station that just used a magnetic stripe, I'd probably be okay because I knew the zip code and the billing address. That's something you have to enter into an e-commerce site when you make a purchase. If the discretionary data wasn't really used during the authorization process, then I think I could make it work by creating a credit card from online data. But if the discretionary data was actually used during the authorization process, then the bigger risk is that trying to use the credit card number would flag the transaction as fraudulent and have my credit card company shut down the card. And that might be a difficult conversation to have with their fraud department. Yes, I could say that I was doing security research for my blog and decided to see if I could clone my credit card by using a magnetic card reader I bought on eBay. I just wanted to see if I could bypass your security systems by making up the discretionary code on the magnetic stripe and try to use it. What do you think? Yeah, good luck with that conversation, and good luck getting another card from the bank and not getting flagged for life, or having the FBI or Secret Service show up. So I thought about using a credit card that I didn't use at all, that much and didn't mind if it triggered something with the credit card company or got flagged or rejected. But in the end, in the interest of not getting into a ton of trouble and for the purposes of this publicly posted blog, I chose option number 3. I'm going to pass. So while it's impossible to encode a blank card and either put blank numbers or other numbers in the discretionary data, I decided that this was where I would stop. Even though I was going to do this with my own real credit card information, I didn't want to start guessing the discretionary data in Cvv2 code. So don't try this at home or at a gas station, and don't try this with a credit card number that isn't your own. I wasn't trying to defraud the gas station. I was mostly just curious. But if you do try this with a stolen card, there's a lot of other ways you could be caught. First, there's cameras everywhere, and it would be pretty easy to have a camera record your face using the pump, or photograph your license plate, or some other methods that I'm not even thinking of. So, to sum it up, if I have physical access to your card, I can run it through a skimmer, like this one, to record the track information on the card and then write down or photograph the Cvv2 code written on the card. Based on the name on the card, I could do a quick web search to find in the billing address, typically where you own your house, though not always. With the physical access to the magnetic data from the card, I can clone the card pretty easily and use it at a gas station or another place that doesn't require a chip reader. I can also use it online if I can accurately find the address information as well. But without physical access to the car, and just based on the data that I gathered from credit card information entered onto a website, I could use the information to make purchases online. Although I wouldn't want them to ship to a place that could trace back to me, right? So if I could clone the card, I could make up discretionary data for tracks 1 and 2 and then use the card in the real world at places that don't require a chip. Although I didn't test this part out. So in the end, based on the discretionary data encoded onto the magnetic strip of a credit card, it would be really difficult to clone a credit card using just the data gathered online. My advice? Keep your credit cards close and safeguard your website, especially if you're taking credit card payments online. Until next time, I'm Jeff Finkelstein, founder of Customer Paradigm in Boulder, Colorado.